Hello and welcome to Hadoop Exam Learning Resources. In this session, we'll be covering the fundamental of Apache Zookeeper. Mainly, this we are covering because it is being used in Hadoop framework to do failover for various components. So we'll understand the basic concepts of Zookeeper and how it helps in the Hadoop framework. So there is a lot of confusion what exactly this service do in the Hadoop framework. So to understand this basic concepts, we are creating this session. So let's go through this. Zookeeper service is mainly you will be using only where more than one nodes in the cluster is involved in your application. Any application, if you are creating your own application which involves like more than one node, like two Java processes on a different system, you want to communicate between these two processes, then this Zookeeper service will helpful do this communication. So in Hadoop framework, there are like name node is main component where this service is very much used. Actually, it's the part of this now Hadoop framework. You have to use to maintain the failover, correct? So like example of Zookeeper services which we using, it's like Hadoop cluster, Kafka messaging engine, like which node will process which message. We'll see the scenarios actually on this, and the Storm. This is again real-time data processing engine. So there is also in this all framework you need know more nodes are involved, correct? So that's the reason. So what is exactly the purpose of the Zookeeper? Zookeeper helps in synchronizing the information across the node in cluster. Where does Zookeeper store this information? Zookeeper store information in the memory as well as on disk. The reason is in memory is like it has to be like available within a fraction of second. So that's the reason it has to be in memory. And again on disk, if there is a failure in the process, then this information should be available on disk. So this keep the information at both the places, on the disk as well as in the memory. In memory, it will help us to the faster failover. Okay, so what exactly this component is known as, where this information is stored, is known as Znode. Actually, that is a Znode where this whatever the information you want to share among the more than one system needs to be stored in Znode. So Znode is nothing just a single file, very small file which contains this data in memory as well as on disk. Okay, so let's me give you the example. Suppose you have some configuration data, correct, which you want like whatever configuration on this node, it should also be available on this node. Some configuration, some XML configuration, correct. Both the nodes should have the same configuration. Now what happens, you are updating this configuration information on the node 1. So how node 2 can get this updated information? So there are multiple ways, but Zookeeper can help us like this. Zookeeper can communicate this is Zookeeper server. Okay, so this can be on the same machine or it can be on a separate machine. It not necessarily be on separate machine, it can be on one of the node, but it should be it is capable of communicating between these two nodes. Like this node also can communicate with Zookeeper, and this node can also communicate with Zookeeper. So whatever information you are updating here, same this node will update in this Z node of this Zookeeper, and same information would be updated on node 2. So that's the way the both the node 1 and node 2 remain in the synchronized state. So like have both the, so some configuration you have deleted from on node 1, so that needs to be updated on node 2. So this information immediately passed on the Zookeeper, and Zookeeper in memory information, so it's very fast actually, and immediately it would be available on node 2. So if somebody is reading from node 2, will also get the latest and updated state of the configuration. So that is one example. Let's move in another. So Zookeeper server is used mainly for coordination among the nodes in the cluster where multiple nodes are involved. So the very basic thing about the Zookeeper, it's a very basic thing. This is the purpose, actually the whole purpose, but we will see various scenario where it can be used. Now let's say Zookeeper in message processing engine. So let me show you this example. Okay, so suppose this is your messaging queue. Okay, from where you are fetching the messages to be processed. This could be your task or whatever. It's just messages, correct? So this needs to be stored somewhere. It could be a data messages, it could be a process messages, anything. So that needs to be either processed or either stored somewhere. Now there are in your cluster 4 node involves, like node 1, node 2, node 3 and node 4. All the nodes listen this queue and process the message. Now this node 1 has fetched the message 1, 2 and 3. node 2 also fetches message 2, 3 and 4, and this fetches 1, 2, 4, and it's like overlap. All the node have like a overlap of like which message being like fetched from the queue. It like because the same message can be fetched by multiple processes in the system, correct? It's a queue, it's a how you configure it. Because of reason being like message 1, if you are fetching from this node, it should be available on this, and or it should be available on this, and or say at least 3 machine in your cluster, let's say. The reason being, suppose this node goes down, then still my message should be processed, correct? So suppose this node 1 goes down and the message 1 is still available on this node. Now how this communication happens, like node 1 is processing message 1, and node 2 also has message 1, and node 3 also has message 1. So to avoid the duplicacy, like same message cannot be processed, should not be processed by the more than one node. How this information can be synchronized? So there is a Zookeeper server which is connected with all the node in the cluster, and this Zookeeper server has the information, like this node 1 is processing message 1, so other node should not process this message 1. So as soon as suppose node 1 goes down, so Zookeeper has this information. You have to configure obviously this thing. So like Zookeeper has this information, like message 1, 2 and 3 was on node 1, but node 1 has crashed, this is no more available. So that's the reason this 1, 2 and 3 message needs to be processed by some other node, correct? Either node 2, 3 and 4, anything. So here node 2, 3 and 4 can process this 1, 2 and 3 message which is available, which was on the node 1 and what's being processed on this. Similarly, like any node in the cluster can fail, so Zookeeper server has to have this information in their Z node, which can be used by other node in your cluster, so they can get to know like which node is alive, which node has died, which node has been is processing the message 1, 2 and 3. So this is all communication. How would you do if you don't let's assume it, if you don't have this component altogether, correct? And now those 4 nodes which are listening this queue, and messages are being dequeued by each node in the cluster. Now they are independently processing the messages. How they can communicate with each other, like which message I am processing and this should not be processed, because after processing the message they all are storing in the same database, let's say in Oracle somewhere, they in the database they are storing this data. So suppose message 1 processed by node 1 and similarly message 1 is processed by node 2, so both the messages goes to the let me draw here actually to show you. Okay, just a minute. Let's say this is the scenario, correct? Now this is your queue. This is node 1, node 2, node 3 and node 4. Now all 3 node, first, second and third node, dequeue the message m1, 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 correct? All 3. Okay, so now node 1 has processed m1 message. After processing, that needs to be stored in Oracle database. So similarly all 3 nodes process the same message and store into the Oracle database. So this is an like to avoid the failover scenario, we are processing the same message on a multiple node, correct? So now how would know the each node, like which node is processing which message and I should not process it? So that's the reason the Zookeeper service is introduced, and this information is shared by among all the nodes we're sharing, like which node is processing which matches. So this help us to communicate like who is processing which and who should not process this. So this kind of synchronization and coordination is required, correct? So there is a one coordinator. So this is Zookeeper server here working as a coordinator, correct? So which node is processing which message, this information is stored in Zookeeper. Okay, now let's say this is one of the coordination, correct? Now let's take another example, leader selection. Okay, so let me draw here again. Okay, let me we already have drawn this image, so don't you? So okay, so let's say you have 3 nodes in your cluster, node 1, node 2 and node 3. Any service which in your system you have designed, it needs to be processed by only one machine at the time, and it is the leader machine, and which assigns the task to another machines to if something needs to be done. So this is your leader. Okay, so this is your master node, let's assume it in your cluster, and this any communication which happens in this to this cluster should be done using this master node only. So you are doing some work, you need to submit to this node, master node, and now master node's responsibility to distribute the sub task to the each node in the cluster, and some task can be processed by this node. Now this is how this leader have been designed, who which node would be the master node. Either you have fixed IP in, and you make this would be the my master node, okay, but that is not a good scenario, where because this node may crash. This is a system finally, so it should be like system should be like capable of like handling the, like if my master node goes down, other node should become a master. So how this can happen? So there is again Zookeeper service which help us, like which keep this information, like this node is a master node, node 1, and it is still alive. So suppose node 1 goes down, so Zookeeper will immediately make another node as a master node, because it within a fraction of second it can get the information this node is down, and another node should be the node 2 and node 3 should become a master, and then you will be serving your request would be served by the node 2 if suppose node 2 be the master, correct. So there is a lot of configuration needs to be done to this achieve this thing, but there is a this is the purpose of the Zookeeper component. Our intention to here to learn what is the purpose of the Zookeeper. So that is the leader selection. So this is mainly used in the name node failover, which we do. Okay, the same thing I have written over here, so you can read it, and I will share this document as well with you, so you can download. So if you are watching on the YouTube, so you can download under from the description section, or somewhere wherever you are watching this video, under the description section of that video you can get the link to download this document. Okay, and so this is the leader selection. So let's take an example of the name node in the Hadoop. If you don't know Hadoop, then just go to the hadoopexam.com. This is our site. Okay, just let me go through this at least once. So this is hadoopexam.com, where we have various training certification material. So Hadoop Hortonworks related certification, we have all three Hortonworks related certification. This is Cloudera related certification. Just a minute. Okay, let me go to home page and then click the Cloudera here. So these are all Cloudera certification material available. These are all trainings available here, and we are keep updating this, and we are actually continuously upgrading our material. So if you want it, you can just subscribe hadoopexam.com, and please visit at least once. Actually the similar training material and certification material will get it here on the hadoopexam.com. So now let's move ahead again. So now let's take a Hadoop active and standby name node. If you remember, Hadoop framework 1 was having a single point of failure, and that is the reason the Hadoop framework was not becoming so it was popular, but it was not being adopted by many of the organization, because it can crash, and it can, whatever data you have stored, it can you can lose it. So there was no better configuration of it. But after, when Hadoop framework 2 comes into the picture, there is a solution implemented, and this solution is implemented using the Zookeeper service. What exactly do they do this? There are two name nodes. Actually, name node is the information where you store the like metadata of your entire Hadoop file system. Okay, that's all we can in one line we can say right now. Okay, so suppose this name node goes down. If both the node goes down, then your cluster is gone. Okay, so generally this happens very less frequently. Even you can have more than one name node in your cluster. So suppose, let's say we have a name node 1 and name node 2 which store the entire Hadoop framework configuration, file data configuration. So there is Zookeeper failover controller services installed on the both the node. Okay, what is the purpose of this Zookeeper failover controller services? Like it monitors, like if name node 1 is in active mode, so name node 2 will remain in a standby mode. Okay, so this is all the requests would be processed by name node 1. Okay, so suppose any configuration or update happens on the file system, that needs to be go to the name node 1, and this information shared to the journal node. I'll tell you what is journal node, and this 3 journal nodes are there, and what this all 3 would have this information, and as soon as this information is available here, it will go to the name node 2, and name node 2 will have the same information, same configuration which name node 1 has and name node 2 has. So suppose this node crashes, name node 1 crashes, so Zookeeper failover controller immediately get to know this node is no more available, so this node should immediately become a master node, active node. Okay, and the administrator can fix this meantime, this name node, because they will get the alert and all this thing. So name node will have the exactly the same information which name node 1 is having. So all your requests would be processed by name node 2 now. Okay, so now let's come to the journal node. Journal node has a, it's a different thing. It's nothing related to the Zookeeper right now. Actually what happens is, these are the journal node. This is like a quorum, you can say. If some configuration you are changing on the name node 1, so it has to be updated at least majority of your journal node. These are daemon process, very lightweight process. If you, as soon as you update, like is you, it should always be an count or number of the count. So there is a 1, 3, 5, 7. That is the good way to configure the journal node. The reason being to find out the majority. So majority means if we have configured 3 node, so at least whatever configuration you have updated needs to be committed on 2 node. As soon as it is committed on 2 node, this update is considered as a successful commit, and once it is successful, then name node 2 also get this information from this journal node. So this is just a this is also known as Quorum journal manager. Okay, so the reason being, it's like majority, you have to commit your update at least majority of the journal node you have configured. So here 3 node, so it does depend on the size of your cluster. If you have a 1000 node cluster, so there could be like 7 or 9 you journal node you will configure. So at least 3 should be there. So if as soon as on the 2 journal node this update configuration is updated, so it would be like considered a successful update, and then the process can move ahead. So that's the concept of journal node. So journal node has nothing to do with the Zookeeper. Actually Zookeeper, the failover controller, is just to maintain the like. So there are two things actually just to mention here. Journal node, purpose of the journal node is to update the configuration to the name node 2. So whatever configuration is being updated on name node 1 would go to all 3 node journal nodes and then updated into the name node 2. The purpose of Zookeeper failover controller is to maintain like it's a like both the node is alive, then this node is a active node, and this would remain in the passive node. As soon as this node crashes, Zookeeper failover controller, this one will get to know like node 1 is no more available. Immediately it switch over this node to the active name node, and it would become active, and this would be needs to be fixed by the administrator. Meanwhile it will serve this all the purpose, and exactly the same configuration both the nodes should have before starting the serving the request. The same thing I have written here. Actually you can read it. Okay, that's the. So now Znode is just a file that contains information which needs to be shared across the node in a group. For example, group of name nodes, group of message processing nodes. Any node from the group can watch this Znode to monitor the change in the information stored in it. Okay, so that is one. Quorum we have already discussed. Quorum means there should be certainly majority required. So this is the journal node and all this thing which we have already configured. So there is a Quorum journal manager, like this is the responsibility of like this QZAM daemon process, which will take care like at least majority of the node out of 3 journal node should be able to like write before making it a successful commit. So the same thing which we have discussed. So that is what the purpose of here Quorum journal. It has nothing to do with Zookeeper. Actually there's just in between it comes in, so I just try to add this here, so it would be just basic concept would be clear, because there is a lot of confusion between journal node, Quorum journal manager, Zookeeper service, and kind of thing. Okay, so this is all the processes are daemon processes already available on the Cloudera framework, on like Cloudera manager. Using the Cloudera manager you can configure it. Using the Hortonworks Ambari framework you can configure this thing. So this is like a similar concept across the all the vendors in the Hadoop framework. You can use it. So that's what we have covered in here. Like, so what is Zookeeper, what is Znode, what is journal node, and what is leader selection. So that's all about the session. Thanks for watching, and I hope you like this session. I would definitely suggest you please go to this hadoopexam.com. just try our demo sessions, demo materials, so you will definitely like it. We are serving since last 4.5 years to the community, and We have more than 12,000 subscribers till now. So I hope you would also like this. And this is not only about the Hadoop framework. We have the Amazon Web Service solution. We have SAS, data science, HBase, Hortonworks, Mapr, Spark. Many products are there. It's a cloud. Cassandra is we are developing for the Cassandra as well. And for normal programming like Java, Python, Scala also we are having. So a lot of products are available here. A lot of learning resources are available here. So I would suggest you plus visit at least once, so you'll get to know what exactly we are providing here. And also I would suggest you to subscribe here. Just click subscribe here and put your email ID and name, so whenever we do update something, you will get to know like what exactly the updates are happening on the hadoopexam.com, because we are continuously upgrading our existing products as well as the new products will be launched. So I hope we will be able to provide you, this is the URL hadoopexam.com. Okay, so this is just the URL. uh, Sorry, just that is very simple, hadoopexam.com. There is nothing special. Okay, so just visit this and thank you. And you can become an author, trainer, and you just click here. You can subscribe us. You can send your detail. We'll get to know about you, and we might need your help to develop. And you will get good revenue sharing with us as well when you subscribe on this. So thank you. And if you are watching on YouTube, finally, I would suggest please subscribe on YouTube as well, because whenever we upload new session, you will get the notification. Thank you very much.